Thank you, everybody. Thank you for coming in this late. So thank you for the introduction. Today we'll be talking about Arabic natural language processing, challenges and solutions. And I first want to explain what this New York Abu Dhabi business is, because if you're curious. So New York University, obviously in New York, has expanded in the last 10 years, and it has 14 different campuses around the world with two portals outside of New York. So this is Abu Dhabi and Shanghai, where we have students come in and actually have, it's an undergraduate program, and we also have PhD programs through NYU in New York. And I work in the Abu Dhabi campus. So in case you don't know where that is, this is Earth. Going closer, this is we're here. This is the Arabian Peninsula, right? Arab Emirates. And although it is very deserty looking, and in fact, we are a collection of islands in Abu Dhabi. It's something people don't usually know, so have good seafood. And we are on this little island at the top. So Abu Dhabi is an island, and we're an island off an island. And this is becoming kind of the cultural center for the city. This new building right here is the Louvre, the French museum that just opened in Abu Dhabi. And so this is what the campus looks like. So it's kind of an ivory tower on an island, you know, kind of all of the metaphors of not being connected to the rest of reality, but it's great because we get to focus on research and do our work, and I really enjoy living there. Just kind of some pictures from the university. So our students actually come from all over the world. We have about 1,300 students right now. The target is to reach 2,000 in steady state, and 120 different nationalities. I have some Ukrainian students actually who were very excited that I'm visiting Kiev, and were giving me like all recommendations for what to eat and what to do around here. About 15% Americans and 15% from the United Arab Emirates, but students are really from everywhere. So for somebody working on language processing and computational linguistics, I love teaching there because I have a class of, let's say, 15 students, and there's 10 native languages in the class, and you just, you know, just discussing language, discussing how do we deal with problems of language computationally is really interesting there. NYU is a liberal arts model university, meaning that students actually don't declare a major until the second year. They come in, they take classes whichever they want at the university level. Computer science is one of the stronger programs right now there, and almost all of the students are covered with scholarships. So they usually come in and they have scholarships from the UAE government. It's part of their plan basically to educate a lot of younger smart people about that region. Many stay after they finish, and many also just go to other schools afterward, or graduate school, work in industry. So I specifically am the director of a lab called Camel Lab, like the animal, but stands for Computational Approaches to Modeling Language. And our areas of work are artificial intelligence, natural language processing. There's a lot of focus on Arabic, even though we don't do Arabic exclusively. So, I mean, this last year we had, for example, efforts on Arabic Japanese work, in addition to working with a lot of English, of course, because you kind of have to. The Cavaliers are my team. So these are the people working in the lab. Some are PhD students. We have a PhD program there, as I mentioned, and we're always looking for more people, actually. So now back to the talk. And by the way, for the talk, if you have any questions, just raise your hand, wave if I'm looking in the wrong direction, and I'm happy to answer questions as we go. You don't have to wait to the end, okay? All right. So back to the talk. Natural language processing, well, what is that? I'm gonna do the talk in general, kind of with a bit of explanation of a lot of terminology I'm gonna use before I jump into the Arabic details. Grammarly, obviously, is natural language processing, but there's many other things, you know, that go from Google Translate, information retrieval, you know, sentiment analysis, chatbots. There are just so many things. There's a lot of interest these days in working on them. And computational linguistics is another term that's used for it. I will use NLP a lot because that's what the term means. I don't mean neuro-linguistic programming. that's a different talk in another place. And now as everybody's talking about AI, we feel kind of forced to use the term AI, even though it's more of an umbrella term, really. It's a language AI, I suppose. It's a very interdisciplinary field. People come to it from many different backgrounds. I personally came to it from computer engineering and linguistics. I had 2 undergraduate degrees. And then I did my PhD in computer science working on machine translation. I actually did not work on Arabic because there was no funding for Arabic. But you can tell by now that I got my PhD around the time, just around 9/11 in the United States. After 9/11 in the United States, a lot of funding for Arabic and a lot of interest in Arabic. And that somehow was where a lot of what I was interested in ended up actually, we got a lot of funding from the US to do this research. And it's the challenge that we all have, what do you do with the money? You actually build things, you publish them. The tools that we build are actually public and they're used everywhere around the world. So I'm very happy with that work that was done. But some people come to it from cognitive science, psychology, and other areas. And obviously this is one of the earlier things were machine translation and cryptography in the olden days, and today still. Now, different names of applications, this doesn't really matter. I want to point out the difference between applications and enabling technologies. So applications usually think of as something that a user will actually will use. Something like, I want to translate, here's a box, I have an input language, I get a target language out, I'm happy. I have Alexa or Siri, I ask a question, I get an answer, that's an application. It's a big black box, an application. But within it, there are lots of things that we developed that are called enabling technologies that themselves are not actually useful on their own. They have to be part of a bigger story. And these are things like tokenization. How do you chop a word in a language that is morphologically rich, that has a lot of different parts to it, so that a machine can actually process it well? This particularly is an issue in Arabic. If you look at the thing on the top, that's a single Arabic word that translates into, and they will write it. Right, 5 words in English written as a single word in Arabic. So one of the things that we would do is take this word and chop it up into smaller pieces. And then the question is, what are the right small pieces? Do you chop it in all the letters? Do you do certain combinations of them, etc.? So this becomes part of the research of figuring out the best way to process the text so that you can develop a stronger, let's say, translation system or a speech recognition system, etc. But on its own, it's not an application, right? Nobody says, I wonder what the chopping of this word would look like. They usually care about, translate this for me. Does it make sense, right? Other things are like part of speech tagging. Can you tell what word is a verb, a noun, an adjective, etc.? Syntactic analysis. Can you diagram the sentence to say, who's the subject that did what verb to what object, that kind of stuff. Okay, so among the techniques in natural language processing, there are a whole class of things that are rule-based, or sometimes now called intuition-based, meaning a human sits down and says, well, I think what's happening here is that subject should appear before the verb in this language. So I'm going to write a rule describing this, right? And I'm going to write lots and lots and lots of other rules, and I'm going to say that the verb and the subject should agree in the way, the plurality, person, etc. And depending on the language, this can be harder or easier. Now, this is what people have been doing for quite a long time. And in the last, I would say, 15 years, it got a big hit with the statistical approaches, kind of taking just generally machine learning, becoming kind of the way to go. And machine learning approaches says, you're trying to model the same thing, right? I mean, it's not about we want the same target of the performance, but the way we approach it is different. So instead of a human writing a rule, statistical approaches or machine learning approaches in general, you give the machine examples of what the input and the output is, and then you design an algorithm around it so that the machine would learn how to go from a particular input to a particular output, right? And there, the trick is really the 2 parts. One is, do you have enough examples? Are they good, clean examples? Are they examples related to the case use that you're interested in? So, you can build a system for translation using the United Nations parallel data set, and then you cannot expect it to work well on Shakespeare, right? It just, a lot of vocabulary would not even be recognized to start with, right? But effectively what we're doing here is learning rules. rules from the data that we have to be able to model the input and the output as a big black box. And currently, machine learning techniques are the dominant ones in the field, and what used to be statistical was kind of popular. Now, neural methods are the ones that are really dominating more. Although what you find in practice, on the wild, kind of how people actually build things in companies and a lot of systems, is a mix of all levels. There are some times when it's not really worth it to go and get enough data to train a neural model how to, separate punctuation. I can write it with a simple regular expression. I would be done. It's a simple rule. So it's really about figuring out what is the right level of using all of these things. In some of the work that I'm going to present today, we actually mix within the same system components from different types because partly they exist. We trust, the quality that they produce in terms of precision and recall, and we want to mix them together. Okay, so when we talk about data, I gave an example of the United Nations as a parallel corpus. It's always the question of what is the input and what's the output, and can I get examples of it? So when we talk about something like sentiment analysis, if you want to build a system for sentiment analysis, you need lots of examples of sentences with their sentiment attached. So all of those happy, sad information that you click on your friend's post on Facebook, that's actually training data for Facebook. They can use this to build better systems to predict in the future what the emotion connected to a particular system. And same thing, speech recognition, you need a collection of audio with the transcripts and so on and so forth, right? Now, of course, machine learning and human learning are quite different. So this little baby, when it comes to language, is general linguistic theory today is that humans are predisposed for language, that we have a particular kind of language instinct where we're able to, by age 2, with whatever limited exposure of language that we can learn the language and we can produce sentences that we've never heard before. So something about kind of programmed, predisposed, instinct, etc. The machine, of course, is not, and that's why the algorithms are necessary to figure out how to actually learn from the data to build these rules. So developing algorithms is extremely important, but also data is still very important. And I would use the same analogy with the human. If you take a baby and you put it in an environment where they hear only one language, they're going to speak that language. They're not going to know another language. They hear a lot of swear words in that language. That's going to be part of their basic vocabulary, right? And that's similar to kind of Shakespeare versus UN. So even though we talk about English having a lot of resources, a lot of data, it's not necessarily always true for every domain, every genre, and that's true for every language on earth. I mean, Arabic is in the same situation. The standard language, which I will talk about later, has a lot of resources relatively, but its dialects don't. Literature doesn't, poetry doesn't, and so on. And this is a challenge for when we're developing these systems, how to actually cover these pieces, how to adapt perhaps between what we know from one context to another context. So why is Arabic hard for NLP, or is Arabic hard for NLP? I mean, I assume here very few people know Arabic, and those who do may not have necessarily worked with it in a computational setting, maybe one exception. So this would be like a little intro in Arabic related stuff. So Arabic is written in what's called the Arabic script, and the Arabic script is an alphabet, what's called a consonantal alphabet, where we basically primarily write the consonants in the language and not the short vowels. The vowels are just, they can be written, but they're dropped often. It's written from right to left. The Arabic script, although it's called Arabic script, is not just used for the Arabic language, it's used for many other languages. Kind of like saying the Latin script or Cyrillic script is used for multiple different languages, and there's a long list of languages. So actually the circles there on the side are some of the symbols from the Unicode set for Arabic. The green area is the one that's used for standard Arabic. All this other stuff is used for many of the other languages, some of which are not connected to Arabic in any way historically, other than because of the influence of Islam, let's say at some point being part of one empire. But like Persian, for example, is actually closer to English topologically in terms of its, and there's a lot of vocabulary in it that actually are closer to English than it is to Arabic, but it's written in Arabic script. So as I said, Arabic script is written with what's called optional vowels or optional diacritics. These are these little symbols that we write on top and below this letter. This is the letter B. It looks like a boat. to remember. It has, so this is ba, this is bu, this is bi, etc. And often, children learn this, and foreigners, when they learn Arabic, learn this. But then usually by age 7 or 8, if you're an Arab child, you stop actually needing them. And in fact, in news text, we find them 1.5% of the words have one diacritic, maybe, and sometimes on the wrong letter, because they don't matter anymore. It's just for a person who actually is comfortable with the language, they can figure out the meaning out of the context, and they're not thinking necessarily of how to pronounce because they know the language. It just hints basically for how to remember. Think of it on a scale of kind of variation from here to Chinese, where the hints for the phonology are almost zero, right? At least here you get some phonological hint. Arabic, Hebrew, Syriac, they all do the same thing. Basically, Semitic languages tend to write this way. Here's an example of what the text would look like in a news article, and if it's fully diacritized. For Arabic speakers, readers, this looks extremely busy. It gives us a headache to look at because it's just lots of things saying, look at me, look at me, look at me, look at me, I'm important. And it's like, it can't be true, So this is not actually comfortable to even look at. Now, this, of course, you can expect will lead to a lot of ambiguity. But the question is, how much ambiguity? So a word could mean lots of things as a result. So often this example can be seen sometimes in some books talking about, Arabic is ambiguous. If this was English written in the same spirit of writing Arabic, here is what it would look like, right? So can you guess what this says? With no vowels, exactly, right? So you still could figure it out, obviously, right? And this is not completely true, because in fact, vowels that appear at the beginning of the word are always indicated with an extra letter that says there's a vowel here. We don't not have a vowel. And vowels at the end of the word sometimes have a special character that carries them. So if you have the beginning and you have the end and the word is short, you're missing a couple of them at it, often as a signal, right? I mean, even though if it's not a complete signal. So if I had to kind of modify this and think of English having the stressed vowels are indicated, the unstressed are not, vowels at the beginning are all indicated at the end, you end up with something like this, and this is actually readable. What am I doing? This is actually readable. It does look like text messaging today. And in fact, a lot of people working on text normalization for English would expect this kind of input have to be modified. So I usually joke about, the Arabs have been born, 1400 years ago, we were ready to text message before everybody else. You guys are just catching up with us. You don't really need the vowels as much as you think you do. But it's still, now for a computer, in the case of Arabic, not putting this information means that a word on average has 12 different analyses, 6.8 different readings, and almost 3 different core meanings, right? I'll give some examples of this. So this ambiguity is problematic. On top of it, when people write, they don't always write carefully. So you find examples of spelling errors. I thought I have to talk about spelling errors since this is Grammarly. So you have a lot of examples of spelling errors. A few years ago, I was the PI on a project that annotated 2 million words of Arabic for spelling errors. What we did is called the Qalb project. The Qatar Arabic Language Bank was funded by the Qatar National Research Fund. And what we did, we built an interface, hired people, got data from Al Jazeera with people writing comments. So when people read an article, they go and they write their opinion. Negative sentiment was the default, I can tell you, across all of these comments. But what we were interested in is taking these comments that we determined to be intended to be written in the standard language, but failed, right? So we looked at all of the ones that are intended to be in the standard language, and we had a higher team of annotators just go over them and correct them for all the spelling and grammar errors. And we found about 30% of the errors have at least, of the words have at least one error in them. And of course, I don't have to explain, obviously, if garbage in, garbage out, if you have a system that expects a certain kind of input for tagging or for parsing, etc., you don't want that. You also want a system that can help you produce better Arabic writing. So this is an interesting problem, that that goes on top of the fact that the vowels are not written. So you could think actually, well, you're not writing the vowels, you should have a better rate of spelling, right? Because it's hard to write those vowels. I mean, in English, a lot of errors happen in the vowel spelling. But even when you drop a lot of these vowels, you still have some other issues too. Now, Arabic is also morphologically complex. So this is the part of the challenges of the talk before we get to the solution. So Arabic is morphologically complex. And what is morphology? Morphology is the structure of a word. So when you say a word like playing in English has a play part and an ing part, you know, you can put the two together and you have a particular meaning that comes, and it's similar when you have eat and eating and dance and dancing versus, you know, play, played, you know, dance, etc. So that kind of knowledge is what we call morphology. And Arabic has what's called a morphologically rich, a rich morphology. There's just a lot of information that is packed in a word. So English is actually atypical. I mean, there's lots of languages in the world that are like this, including Russian, Ukrainian, etc. But also Chinese is the other extreme, where there is almost pretty much no morphology whatsoever. English doesn't have a lot. It's not as interesting. But in Arabic, for example, verbs in principle have 5,400 different forms of every single verb. So all of these, that's not the whole list, are examples of the verb to say. Because you have male and female gender, singular, plural, and dual. You can talk to two people separately and talk about two people separately. Aspect, different aspect, different tense, mood, voice, and then you also have these different conjunctions that can be attached. So the word and or the word therefore can all be written attached to the word itself, which then makes it ambiguous with other words also. And pronouns. So when you see like I saw it is a single word. Because the it is written as part of the word. So you get a lot of different forms. And then within each one of these, if I take this one down here, you get multiple parts of morphemes that correspond to this meaning. So this will say, and will we say it, which means, and we will say it. So we will say it. And you have the ending is there, that pronoun, the it, and here you have the conjunction and it's all just written attached in the word itself. Okay, so 5,400 forms for the verb. English has 6, right? And this is like one of the bigger cases. Many cases have less, like 4 or so of specific different forms. So almost 900 times, right? Just kind of measuring the degree of complexity. When you think about training a system that, let's say, statistical or neural, putting character models aside for those who understand what I'm talking about, you will have, you know, a situation where you may not recognize a lot of words or not analyze their parts properly because you have not really seen that particular context. And so the full tag set for English is about 48, and for Arabic it's 22,000, which makes it quite hard to make a system to predict it. I'll show you how we do it actually when we talk about the solution. All right, so what else is going on? So I mentioned earlier 12 analyses, 2.7 lemmas, ambiguity in the spelling, all of the suboptimal errors that people add. But then those things are kind of come together, and you may end up with a word like this, for example, that has 2 different readings, where in one of them it means and with her pieces of evidence, and the other one says and I exchanged with her, right? There's really very little that's connected. I mean, the her part is kind of similar, but the root of the word, the dictionary entry are really different, and out of context, you don't really know. I mean, that's just, I wanted to kind of highlight the example that some of these things can be quite far away from each other and not connected. And obviously, like almost every language on this planet, words could have multiple meanings in different contexts. So a word like alain, for example, means the eye, water spring, you know, a notable, the name of a particular city. So some are nouns, but they still mean different things. And this is my favorite word, given the politics embedded in it. The word is al-muhtal. It means the occupier, and it also means the occupied. The same word for a concept that should be, people fight and die over who's doing this. It's just really interesting. It's fascinating, right? Our system doesn't disambiguate it, actually. It's not part of our, we just figure out if it's the ambiguous set. We don't actually go to the semantics right now. So to do this, to build systems for it, we have to do what's called morphological annotation. And morphological annotation basically says, you look at a word out of context, you look at all of the different possibilities, and you pick the right one. That's what we want the machine to do. So to do that, we have to create examples of it. And for that, we get humans to do this task. So for Arabic, for standard Arabic, there's about 1 million words that have been done in this style. This was work that was done at the University of Pennsylvania in the Linguistic Data Consortium, where basically work is done on standard Arabic, but also on Egyptian Arabic, of people basically just doing nothing but read sentences and pick the right analysis of them. And that's basically what we have right now. In Abu Dhabi, in NYU, we actually recently did 200,000 words for Gulf Arabic specifically, so that we can do research on it. We have to do this at least for testing, right? So we know, is the system doing well or not, but also obviously for training to develop better models. Okay, now the third aspect of, I mentioned the problem with the writing system, the problem with the morphology. It's usually the three things: how you write it, what the components of the words are, and then the dialect is the third problem for Arabic. So Arabic has close to 400 million speakers, a lot of people, and there are multiple forms of Arabic that are kind of currently in existence, let's say, in common use. One is classical Arabic. So classical Arabic is like the language of the Quran or language of the hadiths or the sayings of the Prophet, quite older language. People don't talk this way today, right? They just pray that way. Modern Standard Arabic is the standard common form of Arabic that is the official language across the Arab world. So all of the countries that are part of the Arab League, that's their official language. It's the language you would expect to see in the media, you'd expect to see in newspaper, you'd expect presidents and prime ministers to give speeches in, primarily. And then there's dialectal Arabic, which is the language that everybody speaks, right? This is actually, by how many people speak it, like per second, this is orders of magnitude more than the standard language. It's basically how people communicate. And up to about 15 years ago, people used to say, oh, it's only spoken, it's not written. Today on social media, it's quite common to see it. It's actually the dominant form that Arabs communicate on social media is in dialectal Arabic, not as much with the standard Arabic, although it exists, of course. And then the two forms of the standard and the dialect are not really completely separate from each other. They're kind of, I usually get the question, are these languages, are they dialects? And that is a political question at the end of the day. As the saying goes, a language is a dialect with an army. So if you decide that your dialect is a language, you start creating an institute for it, and you start coming up with different spelling systems for it and change the spelling system, as you wish to make it look different, etc. And the Arab world is kind of in a situation of flux, effectively, in its attitude about Arabic and the dialect. But the two forms kind of coexist together. An educated adult needs to know both the standard and the dialect. Now, the thing about the dialects, and this is a map of the Arab world in terms of its dialectal regions as opposed to the political regions, and you can see they're not really exactly matching. Now, the official language, as I said, is Modern Standard Arabic, or MSA, but it's no one's native language. So this is not like High German in Germany, where there's some area where people actually speak that form. No one grows up at home speaking standard Arabic. Everybody basically goes to school and then learns it in school at age 6, etc. And that's when they start building the two different vocabularies that go together. There was a study from Tunisia that said that about 60% of the vocabulary a child knows by age 6, they have to learn again when they go to school. It's just that different. So basic words for bottle, chair, etc. will be different between the dialect and the standard language. And we often talk about regions of the dialects. So, dialect, Egyptian Arabic, Levantine Arabic, Gulf Arabic, etc. But there's even within each one of these regions, different cities with different styles, and even villages outside a big city may actually speak differently. That is not unique to Arabic. Pretty much every language has these different variations. It's just the question about the fact that there's a standard and how commonly used it is as a native language is, I think, what makes this a bit more different. So how are they different? One aspect of difference is pronunciation. So this is pretty shallow, kind of basic stuff. So this particular symbol, for example, it's standard Arabic, it's pronounced qaf. So I'm gonna say a word for heart is qalb. That's the qaf pronunciation, qalb. But you can also get it as, qalb, kalb, elb, gelb, jelb, and ghalb. right? And it depends on where you are, basically, these kind of variations that happen. Some of these consonant shifts also happen to look like letters that exist or consonants that exist in the language, so you end up creating new ambiguities as a result. But this is one aspect. Another aspect I should point out is this issue of spelling. So, because we work with text a lot, so although there is Arab academies that care about what is the proper spelling of words, reforming spelling, etc., they do this for standard Arabic. They don't do this for the dialect. Most of the Arab academies don't recognize the dialects as worthy of writing up to this now, at this moment. So when you get in Egyptian a word like this one, maybe ulhash, that's a single word that means he does not say it. We found, I think, 27 different spellings by Google search of that single word. So the top one, obviously there when it's called with the Ziphian distribution, where some things happen a lot and many things happen very infrequently. And this kind of brings the question of, are these wrong spellings? Well, they're not really, because there is no official standard, right? I mean, linguists often don't talk about orthography because orthography is not language. Orthography is one way of representing language, and it has to be controlled and standardized. And when you have something that is raw, who says which one is right, which one is wrong, right? So we try to come up with an own systems. One of the aspects of developing technology in this case is that you have to come up with a decision so that the machine will generate in it. Otherwise, evaluation is hard. You know, if a system generates any of these as a translation, let's say from English to Egyptian, in principle, they're all correct. But are you going to actually have multiple references of these forms, right? That's not practical. Other example, so tomato, you know, and the British and the English are just fascinated that there's two different pronunciations. You guess how many in Arabic? It's 10 different ways you can say that word. And so, I'm going to say one of Banadora, Tomatish, Tomat, Matisha, Uta, and Guta, and Tamata, Tamatum, and Tomatum, right? So you have the vowel difference. So that's just a lot of different forms of saying this particular word. In some cases, the variation in the pronunciation is in the consonants. This number 2 is the glottal stop. It's like a sound. So Guta and Uta are two different ways, but it's written typically in one way. And in other cases, the difference is actually all in the vowels, the quality of the vowels. So Banadora, Banadura, Bandora. During the Lebanese civil war, people can be killed if they pronounce the wrong form. It's a shibboleth that was used basically to stop people at checkpoints and say, how do you say this? And if God wanted you to disappear, you know, anyway. So variation in pronunciation can have very strong significance, not just a little vowel somewhere. Other things that happen between the dialects and the standard Arabic is simplification in general. So this is similar to what happened with, let's say, Latin and the Romance languages. So French and Italian and Spanish lost cases. All those tables of declensions from Latin gone. Same with Arabic. Standard Arabic had, just as an example, like for the word kitab, it's kitabu, kitaba, kitabi, kitabun, kitabin, kitab, the other one. And they all just disappear to kitab or kitab, right? In most dialects, there's no dialect that currently has a fully functional case system. And in some cases, things like plurals for men and women just merge into a single form. And in some cases, oddly, one part of the Arab world takes one form of the paradigm, another part takes the other form of the paradigm. So they just almost like splitting an inheritance between the standard language and the different dialects. But we think this sounds good, right? Simple, simple, simple. That's nice. Not completely true, because some things become more complex, particularly this issue with the clitics, these little particles that attach. So clitics in English, like you don't have them. It's really like can't and won't, like would not or cannot becomes can't. So these kind of formations that looks like this. In Arabic, 20% of the words have them. So there's a lot more stuff happening. But in Egyptian Arabic, in this example, there's even more, where we get negation, circumclitic. They're a clitic that has two parts that attacks from both sides of the word, and that tells you this is negative and negated. And then also you get an indirect object, something that not just him, but it's for him also. So I gave to him it, for example, as distinctive. So here the word, it's not my dialect, so my pronunciation would be awful. وَمَا كَتَبْتُ هَلُوش is a single word that means, and you did not write it for him, as a single word, right? So, and these words happen. I mean, we find them in the data that we work with. So here the complexity happens, some parts become simpler, some parts becomes harder. And when we're building models and we say, well, why can't we just use the standard language system that you have on the dialect? Well, the results are not so good. I'll show you some numbers in a couple of slides. So to put it all together, the challenges are a lot of orthographic ambiguity, how it's written, things are missing, a lot of inconsistency, complexity of the morphology, and then the dialectal variations. Many of these happen in this word that one single spelling of this word can give you these different diacritization, and he stresses us out with our contract, with our necklace, and with our psychoses. You can try to figure out the connection between them, it's quite hard. But again, this is the degree of ambiguity we're talking about. So when we compare to how well we do computationally compared to English, and you get state-of-the-art for part-of-speech tagging. Now, English has a smaller tag set, as you remember, about 48. So you get to 97 or so % accuracy. The comparable level for Arabic is 85, much lower. And if you just look at the core part-of-speech, we're getting closer to English. Egyptian Arabic is quite behind on all of these. And also dependency syntax, or the syntactic analysis of what's the subject, what's the verb, what the object, we're also lagging behind. English has more data. A lot of the algorithms were designed with English in mind to start with, even though the claim is usually this is language independent, but there's certain expectations about the way languages work that makes it more, amenable to languages like English. And if you look at the quality of translation, we find that this is from Google Translate. I don't need to explain that the stuff in the red is basically just garbage translation, either wrong or the output was just generated by transliterating literally what was said in the input. Part of the problem here, of course, that there is not enough parallel data. So for standard Arabic, you will have a lot of examples of data from the news or the United Nations resolutions and things like this, political context. But when you go to colloquial text, there is not what I would call natural parallel data, meaning some parallel data of text that was created because humans want it to start with. So there is no, for example, parallel data, naturally occurring parallel data between the standard and the dialect, or one dialect and another dialect. So what we ended up doing is actually creating that data so that we can, but it's not natural, obviously, it's commissioned in that case, so that we can actually build models and study it. So this is a big part of the challenge for them. The amount of research, of course, this goes without saying. English is kind of the dominant language. This is just the number of publications since 2000 or so, where word natural language processing in English or Chinese or German, Hindi, Arabic, or Arabic dialect exist. And English is, everything is rising. Chinese used to be behind German. Now it's better than German in terms of the number of people working on Chinese specifically. And Arabic is also, is there. We're trying to rise up in the counts, but there's many other languages. Hindi has, a lot more speaker than Arabic, and it's even more behind, right? So I don't need to explain the history and the politics of this. So now I'll just go through some examples of some of the things that we're developing at the lab in Camel Lab in NYU Abu Dhabi that are solutions, and hopefully that I've explained what the problem is. You understand and appreciate what is the point of the solution that we're doing. So the first thing I'm going to talk about is the system called MADAMIRA. And this is currently a state-of-the-art in doing Arabic morphological analysis and disambiguation. And this is, as a system, it uses a combination of rule-based components and also machine learning components that are in the I'm going to show you a demo of it. The demo, we use support vector machines, very light to kind of speed it up online. We currently have a system that we're developing with neural nets. It beats it by far, but it's not ready yet for showtime, for public use, just in terms of the numbers. And we have it for standard Arabic and for Egyptian Arabic, and we're currently working on a bunch of other dialects. So the basic principle of it, this may be a little bit more technical, so bear with me. The principle of it is, when you're building a system, you have a word, let's say this word 0 is the word I'm interested in. We're actually looking at that word in two different ways. One, out of context, through in a black box system, that's a morphological analyzer. So this analyzer is built by hand using rules. It has about 40,000 core concepts and millions of different possibilities, basically, that can be matched according to the concept. And what this does, it says this word 0, out of context, has many different analyses. Think of these little vectors as if they are, every column says, this is the gender, this is the number, this is the aspect, this is the part of speech, etc. And then the color just tells you, is it masculine or feminine? Is it singular, plural, or dual? That's just visually that, right? So there, out of context, we get a word and we say, oh, what are all the different readings of that word? And now separately, we have another component that is a bigger context that has within it potentially separate different boxes that take this word, and then you're not seeing it maybe well. There's a box around it. Looks at the context around the word itself and tries using the context around the word to give you the feature. So one model, this one, will say, okay, I only do gender. You're male, male, female, 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 male, female. Another one says, I only do number. Singular, 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 dual, singular, singular, plural, right? Another one says part of speech, noun, adjective, verb, etc. Right? So they all independently generate their decisions, and then this comes together. Now, this model, we currently do better by actually making the decision jointly, but it doesn't really matter. It's within the same black box. You just have something that will generate these decisions. And then for each one of them, because remember, we have 22,000 different combinations. So if we break them down into about 14 dimensions, we can break them down to something between 2 decisions to probably 35 decisions, right? Which is more like a typical part of speech tagging task. Now, the result is a vector with these gender, number, person, blah, 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 with the different colors. This may be completely impossible. It may actually say, this is a verb whose case is nominative. I mean, that doesn't make any sense. The case goes with nouns, not with verbs, that kind of stuff. Because the model could actually be making these decisions independently. So what we end up doing is use a component that's a ranker that will basically take the rule-based analyses and then basically rank them based on this, on similarity, basically, to what the system is doing, right? So the idea is that we have 2 parts. One part says, here's what's possible for this word. But now you have a separate part that says, in this particular context, I think, it should be male and it should be singular and it should be blah, blah, blah. And then we combine the decisions from each other, accounting for the fact that we may actually have combinations that are predicted that are not possible to go together. And this part gets tuned, meaning the weight of every match could be different. They're not equal. So getting the gender correct may not be always as good or important as getting the part of speech correctly. And we weigh this by basically tuning against a separate held out data set so that we're not cheating. When we go to a new data set that's completely blind to us, we've never seen it, it should be like we know nothing about it. So I'll show you what this looks like. So here we go. So this is an online interface. It's running, it's not a canned demo. This is Al-Ittihad newspaper. I'll just go to another article than the one I was looking at. There we go. And then we'll just take this text. This is, of course, intended as a demo for this kind of purpose, to show you the system itself is built in Java. If you're curious, you can download it, use it, and it has a very nice interface with an API that you can use to plug in with other systems. We've actually had companies use this as part of their work. So this is the speed of it, what happened right there. This was the analysis. I'll just start with this one. This is the diacritized form. So the input doesn't have a single short vowel diacritization. And here we actually get it. And if you know Arabic, you know it got this one incorrectly. But I'll just, I'm always, case endings, the ending at the end of the word is one of the hardest things. It's about 15% error in the system. But identifying the core meaning is 96% accurate. So here, without knowing Arabic, this gives you the gloss also. So it's renew, repeat, clubs, association, European, great, largest, threat, boycott, championship, cup, world. Can guess, the European blah, blah, blah are threatening to boycott the World Cup, right? And all of these different features are basically generated automatically as part of this analysis. This version here of the view tells you which parts of the words are the core and which parts are these clitics that I mentioned that are connected. And in some cases, you can see there's more than one that can appear before the word itself. Right, and then also we have here, this is just the list. It's not readable really for you if you don't read Arabic. It's just the list of the dictionary entries. It's one of the hard things for people who learn Arabic is figure out, how do I find this in the dictionary, because it has so many different forms when it's inflected. So this is basically what this system does. So in terms of its performance, as I mentioned, if you look at the full analysis, diacritization, you get similar number. Diacritization, when it comes to diacritizing the middle of the word, we do better. The end of the word where the case happens is much harder. This is one of the weaknesses. Lemmatization, or figuring out the core meaning. Remember when I said there's 2.7 different possibilities? We get this at 96%. In the news, right? The moment we go outside, we did some study on literature where we took like a chapter from a novel and we carefully went through all the answers. That number goes down to 90%. So we doubled the error just by going outside of the domain that we're trained on. For part of speech tagging is 96. And then for segmentation or figuring out this word, let's say, can I chop it up into 3 parts for processing later on, we get that at 99%. It looks like a good number. It's not a good number. I mean, we want this number to go higher, actually, because this is the first step in anything that you process. So when 1% almost is lost, is not so good. Now, this middle column is interesting because the system is standard Arabic, but the test is in the Egyptian. So we had Egyptian data, and 84 becomes 27. 27 accuracy, not the error is 73%, right? A lot more error than diacritization, 32%, and even segmentation is 90%. So this is pretty awful, and this is why we cannot use a system that's developed for the standard language on the dialects. The performance will just not do very well. In the version of the system where it's Egyptian on Egyptian, the numbers are much better. They're still not at the level of the standard Arabic, but that's also because we don't have the same amount of data. So the Egyptian data is about 250,000 words. The standard Arabic is close to 1 million, right? And kind of unfortunately, the more data, the better, but these systems tend to plateau, right? So you don't get a double in the performance just by doubling the amount of the data. I'll just quickly mention, I have a PhD student, Nizar Zalmout, who's been working on taking this MADAMIRA system and making it neural. And in one paper in 2017, he actually demonstrated nicely that using BILSTMs to replace the component in the MADAMIRA framework. Remember the 2 parts? Just the part that is the machine learning component, not the rule-based component. He was able to improve the quality beyond anything that we had done before. And interestingly, he showed that if he uses that component alone without the morphology part, he can actually he can do the same result as the morphology part, but when you put the 2 together, you get even a higher result. So the paper is in a very funny title, starts with, "Don't throw away your morphological analyzers just yet." There's still some good stuff there for them. Our attitude is to try to maximize the benefit of all this work that has been done and combine it together when possible. So another example of work that we're done, and this may be interesting for people here, is Arabic spelling correction. Remember that data set that I mentioned earlier with the 2 million words that were manually corrected? So we actually ran 2 competitions publicly where about 15 or so different groups participated in these competitions. And a student this year ended up beating all of the results from the last 2 years using a sequence-to-sequence model, using character-based primarily for doing this mapping. So this is kind of a nice result. This is, of course, still not a functioning system. It's just a prototype at this time. This is just a note that I had hinted to earlier. Some of the work that we do sometimes as technologists may actually be completely void of any technological decisions. It's actually more about deciding a standard, particularly when you're dealing with a language that is, like the dialects, for example, that don't have a standard. We ended up defining what we call a conventional orthography for dialectal Arabic, or CODA, that is basically the internal standard that we use. We stopped short of calling it a standard because we don't want people to think that we're deciding that we're an institute for Arabic dialects, etc. Maybe someday, but not now. For now, we're basically developing this with the goal of developing better technologies. And initially, this started with Egyptian Arabic. That was one of the first dialects we worked with. And then other dialects came along. And this last year, we had a paper that talked about one system for 28 different cities, actually, called CODA Star. And the details of the rules for this is like one common set of spelling rules, right? Things that most languages, technologists don't even ask that question. You just say, oh, the rules for this language must exist. Somebody has written the rules. In our case, we had to actually come up with these rules. One of two last things I want to mention is a project called SAMR. It's a simplification of Arabic masterpieces for extensive reading. So this is kind of also interesting, relevant to the work that's happening at Grammarly in terms of style, kind of manipulation, etc. So this is work that is between computer science and the Arabic language program in NYU Abu Dhabi. And it was with collaboration with the Ministry of Education, where we basically got all of the curriculum that they use in the UAE. And the goal was to be able to, given a text, can you tell us which part of the text would be easy or hard for children of certain ages to read, right? With the goal of taking this text that's, let's say, Arabic masterpiece, let's say Naguib Mahfouz or whatever, and can you actually automatically or guide the process into simplifying it to the human so that it's readable by somebody who's a sixth grader. And don't forget, this is in the context of a situation where standard Arabic is not the native language, and then you're trying to encourage these young people to read texts of this kind of literature. And in many languages, there are standards for actually this readability level. English has many of these. In Arabic, we don't have such a standard. So one of the things that we're doing is that developing such a standard. And the computational task here is, given some training data that is marked for which grade level, you have some training set, and then you go and you test. You give you a sentence or a paragraph. Can you tell me which grade it belongs to? And then the idea is that to apply this on other texts. What we did as part of this was work that was one with a PhD student, Hind Siddiqui, and she was actually, just want to point you to these two numbers right here. She was actually interested in doing this, not just for text that is for native speakers of Arabic, but also people who are learning Arabic as a second language. And there we have a bit more standards, but not as much data. So as far as the Arabic accuracy level for like figuring out segments of about 100 words or so, we get 94% accuracy at this point, but we're still not pinpointing exactly the parts. And then for the other, like Arabic as a second language for foreigners, it's about 72%. What's really interesting about this particular work is that Hind showed that you could actually use the data for the Arabic for the natives to actually help you with the Arabic for the non-natives, and which is not obvious, right? Because for non-native speakers, usually non-native speakers learning Arabic or a foreign language, they come to it later in life, as opposed to learning it as children. So it's like two different scales, because you'd expect some signal in the language for the children to be more about topics that adults consider children topics as opposed to adult topic, whereas that's not the case with people who are learning a second language. So I'll skip this. I just wanted to actually point out that we actually, as part of this work, we use, go back. We use about 156 features. This is heavy on feature engineering decisions. So a lot of different features were considered as part of this work, including things like syntactic structure, the depth of the syntactic analysis. If you're curious about this stuff, I'll be happy to talk about it more. There's a lot of work that we're doing in this area too. And this is just an example of the interface that we built, that Hind did. So this is an add-on to Google Doc, where the text basically gets marked by which level of readability it belongs to. So you can see this is which grade. Is it basically core vocabulary, grade 6, preparatory, secondary, or fiction, meaning adult, etc. And the idea is that we give this to a person who's going to be editing the text. Their eyes would go to the parts that are problematic, that are higher level, and say, oh, I need to find another word to describe this. So I'm going to rephrase it so that it actually becomes closer to the vocabulary that is acceptable for that grade. And then the last project I'll mention is MADAR, or Multi-Arabic Dialect Applications and Resources. So this is the first project of its kind to deal with the problem of Arabic dialects, right? So beside everything I mentioned about dialects in Arabic and the fact that there isn't any parallel data that exists for them that can allow us to actually, do the science of asking the question, if I control for a certain variable, what is the performance of X or Y? I cannot really do that with Arabic dialects when there is nothing parallel to start with. So what we ended up doing is creating this data set. We picked 25 cities, which was the first time people in linguistics have actually done studies of similar type, not as 25, like about 20 or so city was the largest we saw on a smaller vocabulary, where they basically compare how people say this word across different areas. But from a technological point of view, the scale that we did was the largest scale ever up to now, where it was 25 cities, and we took a large corpus of about 20,000 sentences in something called the Basic Traveling Expressions Corpus. It's a corpus of things people say when they travel. It was developed by Japan, and it has parallels in English, French, Standard Arabic, Japanese, obviously. And it'll be things like, can I get more coffee, please? Or I'd like a room with a window to the beach, please, right? And things like this. Can you point me to the metro? Oh, go to the left and then go to the right. I mean, that would be a complete sentence. So we thought that would be appropriate for a spoken language to create a parallel corpus for it. And for 5 out of the 25 cities, we did all 20,000. And for the other 20, we did about 2,000. Why? We didn't have enough money. It's kind of, the money ran out, basically. So we used all the money to do as much as possible of coverage of certain central cities. We did Rabat, Tunis, Cairo, Beirut, and Doha, because the funding came from Qatar. And then we did lots of cities in between them. And then we end up with like these parallel texts, basically, which are all, you can actually look them up online. Everything is browsable online. So, and including a lexicon that we developed that covers all of the words that appear in it. Not all, 90% of the frequent words. Now, as part of this work, what we did last year is a paper on doing what we call fine-grade dialect identification, which is, so the task is, here's a data set. I'm going to give you a sentence, and you have to tell me which city this is spoken at, right? This is a really hard task. I mean, people cannot do this task very well. And what we did here was, and in fact, the machines does it about 67% accuracy, right? If you pick only, it says 6 labels and 26, let me explain. 6 labels is the 5 cities that I mentioned where we have a lot of data, plus Standard Arabic, right? And the 26 is the 25 cities plus Standard Arabic, right? So there, for the same kind of, for a sentence, can you tell me what is the label? So the task is pick 1 out of 26, right? So the baseline is very low because they're all equally distributed. You don't really have any, if you pick randomly, you're not gonna do very well. And we get 67.9. Now, it's low. We hope to keep increasing it. However, I wanna point out something that was interesting as part of the analysis in that paper is if we decided to do an Oracle study, this is a fake. This is not a real result. It's a fake result. It's an Oracle analysis where we took a sentence, we knew which dialect it's from, but we hid that information from the machine. And we just added another sentence from the same dialect after it, and then after it, and after it, and after it. And we got like 100 words, so that it's as if you are talking to someone, you know Arabic enough, and you talk to someone, and the more they talk, the more you develop your model for how to figure out where they're from. That should feel intuitively reasonable, right? So we simulated this to see, would this work? And interestingly, it does work quite well, at least from this simulation, right? So what we're doing right now is we decided to see if this can actually work in real life. And this is, we don't have the results yet. We collected for 4,000 Twitter accounts, all the different countries they come from. We annotated this by hand, basically. And the idea is that, asking what is the dialect of a tweet, well, that's interesting. But if you say, what's the dialect of the person who wrote the tweet, you shouldn't just look at the tweet. You should look at all of the other tweets that that person produced, right? So the idea is if we have more signal, can we actually do better, even though we have less data for training? So this is kind of interesting if this works out, because often we think more data is better, more training is better. In this case, it's actually more input could help us. we'll see if this actually pans out, if the oracle does not have a bias in it that we're not aware of, but this is kind of the intuition that we're playing with at this point. So this is a competition that is started, actually, it's part of the Arabic NLP workshop that will be in ACL this year in Florence, and the data was just released last week, the full data set. I think if you're interested, there's still time to participate. You can go and register. Okay, so in summary, I'll stop in now. So if you learned anything, a little bit about Arabic. Arabic is hard. It may not be necessarily, well, you're reacting to my, I'm sure there's other languages that are harder, right? But Arabic can be hard, and there is a lot of challenges in it. In some cases, a part of the challenge is that we're working with something that is, has this duality of identity between a standard that has a lot of a long history of standardization and rules and expected answers, etc., and data that naturally occur for it, and then other varieties that don't have that luxury. And it's about basically balancing and working with all of these situations. There's a lot of work that's done, and there's a lot more work to do still. So luckily, hopefully, I will keep working on it. And future directions, we're going to continue working in the lab on other varieties in Arabic. I use the word variety here to cover not just the dialects, but also other types of, even within the standard, like we just proposed an effort, hopefully we'll get it, to work on Arabic from across different periods of history. So text, building part-of-speech tags, etc. It's actually, the name of the project is From Pre-Islamic Poetry All the Way to Twitter. And it's just kind of the whole range of how language have changed over 1,500 years. Interesting, by the way, with all of this stuff, Arabic readers, if they read Arabic, they can pick a text from 1,500 years ago and read it and understand a lot of it without a lot of trouble. The pre-Islamic poetry is a bit tricky, but other than that, like from 1,300 years, it's readable. Arabian Nights is, 11th century, and it's completely readable today. English cannot say that because English changed a lot, in fact, over that same period. So we're also developing new data sets, new algorithms to help us with this work. We're working on a suite of tools called Camel tools, which will be basically a Python toolkit that you can pip install and then just use it as part of your systems that will basically, hopefully, eliminate the need to have to worry about, what transliteration do I use, what morphological analyzer do I use. Just go to the more interesting part that you want to work on with Arabic. And we're also part of developing a center at NYU Abu Dhabi that's a very intense interdisciplinary collaboration with people from sociology, history, the Arabic language program, and also with industrial partners, basically to work on technologies, taking a lot of the stuff that we do in the lab, that's prototype, and actually push it to actually be useful. So, and that's it for me. Thank you. And we're hiring if you're interested, but I'll leave that there. Thank you.